Good morning, viewers at home. Welcome to another edition of Emerald Mathematics class. In our previous lesson, we talked about factors of numbers and we looked at the rules of divisibility of numbers. So today we are going to look at expressing numbers as product of their prime factors. How to express any given number as product of its prime factors. So what are the prime factors? Prime factors are those factors of any given number which are prime numbers. And I believe we all know that prime numbers are numbers that can only be divided by 1 and themselves. For instance, 2. 2 is a prime number because only 1 and 2 can divide 2. 3 is also a prime number. Only 1 and 3 can divide 3. 5 is a prime number. 7, 11, 13, 17, 19, and so on. They are all prime numbers. But not all prime numbers are odd numbers. But most of them, if not all, apart from 2, they are all odd numbers. Now, how do we express a number as product of its prime factors? We are going to take these two examples. Having known the rules for divisibility, we will be able to know where to start from. The last digit here is 2. So that means this number is divisible by 2. So we are going to use 2. 2 is 7. 3 with a remainder of 1. So this 1 and 2 now, that is 12. 2 in 12, 6. We have 36. Because the last digit is even, we can still use 2 again. 2 goes in 3, 1, remainder 1. Then 1 and 6, that is 16. 2 in 16, 8. The last digit here is still even, so we can still use 2. 2 in 18 is 9. Now we have an odd number, which is no longer divisible by 2. We try to use 3 and see if 3 can divide. 3 can divide 9. So 3 in 9 is 3. 3 again in 3, 1. So that means 72 equals 2 times 2 times 2 times 3 times 3. So with this, we have expressed this number as a product of its prime factors. From this answer now, we can see that all the numbers here are prime numbers. So that is the aim of this. We'll express it in form of only the prime factors. The second example, 4,800. 4,800. The last digit from the rules we gave previously is 0. So that means it is divisible by 2. 2 goes in 4, 2, in 8, 4, in 0, 0, in 0, 0. Then we use 2 again because we still have 0. 2 in 2, 1. 2 in 4, 2. 2 in 0, 0. 2 in 0, 0. We use 2 again. 2 in 12, 6. 0, 0. 2 again because of this 0. We have 300. We can still use 2 again. In 3 we have 1, remainder 1. 2 in 10, 5. 0. 2 again because of this 0. This is 7, remainder 1. 1 and 0, 10. 2 in 10 gives us 5. Because the last digit here is odd, we can no longer use 2. Then we check if 3 can divide 75. And if you remember, in the last class we said 7 plus 5, 12. 3 can divide 12, that means 3 will divide 75. So 3 in 7 is 2, remainder 1. 3 in 15, 5. With this now, 25, 2 plus 5 is 7. 3 cannot divide 7, that means 3 will not divide 25. So after 3, the next prime number is 5. And 5 is a factor of 25 because the last digit here is 5. So 5 in 25 is 5. 5 again, that is 1. So my 4,800 will be 1, 2, 3, 4, 5, 6. 2 times 2 times 2 times 2 times 2 times 2. Then we have 3, we have 5, we have 5 again. So with this, we have expressed 4,800 as a product of its prime factors. I believe we understand this. For better understanding on this division that we have just done, you can go back to the previous lesson on factors so that you check the rules of divisibility and know how we got all this. Now let's take another example on this. It's not every time that we'll be able to start with 2. If you are given a number that is not divisible by 2, how do we know which one to use? For instance, if I have 1,215, the last digit here is odd. That means I cannot use 2. Now let me add the digits together. 1 plus 2, 3 plus 1, 4 plus 5, 9. 3 can divide 9. That means 3 will divide this number. 3 in 12, that is 4. 3 in 1, that is not possible. Then 1 and 5, that is 15. 3 in 15, 5. So we follow the same process again. 4 plus 5, that is 9, which is divisible by 3. So we can still use 3. 3 in 4, 1, mean that 1. 3 in 10, 3, mean that 1 again. In 15, 5. Let's add the digits again. 1 plus 3, 4, plus 5, 9. 3 is a factor of 9, so 3 is a factor of this number. 3 in 13 is 4, mean that 1. In 15, that is 5. 4 plus 5 is still 9, we can still use 3. 3 in 4, 1, mean that 1. In 15, that is 5. So this is 1 plus 5, 6. 3 is a factor of 6. That means you can still divide by 3 again. 3 in 15, 5. Then 5 in 5 is 1. So our 1,215 is 3 times 3 times 3 times 3 times 5. So this is how to express a number as product of its prime factors. So we have to be familiar with the prime numbers so that it will be easier for us to do this. Thank you.